Hey there, welcome back everyone. Today we are diving into a very important topic in maths, that is polynomials. I'll be explaining what polynomials are, how to work with them, and important concepts like degree, terms, zeros of the polynomial, and relationship between zeros and coefficients. So let's get started. Let's begin with the basics. Polynomials are algebraic expressions made up of variables and coefficients. We can perform arithmetic operations like addition, subtraction, multiplication, and raise them to positive integer exponents. However, we cannot divide them by a variable. For example, there is a polynomial p of x as x square plus x minus 12. So in this example, the terms x square, x, and 12 are separated by plus or minus signs, and each part is a polynomial expression. Next, let's talk about the standard form of a polynomial. The general structure looks like p of x is equals to a of n into x power n plus a of n minus 1 into x power n minus 1, and so on to a of 1 into x plus a of 0, where a of n, a of n minus 1, a of 1, and so on. These are the coefficients of the terms, while x power n, x power n minus 1, x, and so on are the variables of x, while a of 0 is the constant term. So these constants, coefficients must belong to the set of real numbers. For example, we take a polynomial p of x as x square minus 5x plus 11. So the coefficient of x square is 1, while the coefficient of x is minus 5, and the constant term is 11. So all this belongs to the set of real numbers. And if we change the variable from x to take any other letter like a, then the function becomes p of a. It is as simple as that. Now, let's discuss the degree of a polynomial. So the degree is nothing but the highest power of a variable in the polynomial. For example, in a polynomial x square minus 5x plus 11, the highest exponent is 2, so it is a second degree polynomial. Similarly, in a polynomial 2x cubed plus 3x square plus 4, the degree is 3 because the highest exponent is 3. So this concept is important because the degree of a polynomial helps us to classify it and determine its behavior. The terms of a polynomial are the parts of expression separated by plus or minus signs. For example, 2x square plus 5x plus 4. So here 2x square, 5 and 4 are three terms of the polynomial. Polynomials can be classified based on the number of terms, like monomial, which has only one single term, while binomial have two terms, and trinomial have three, and polynomials. Now let's talk about the zeros of the polynomial. The zeros are also known as roots of the polynomial and are the values of the variables where the polynomial is equals to 0. For an instance, if p of x is equals to x square minus 5x plus 6. To find the zeros, we solve the equation. The solution of this equation are the points where the polynomial actually becomes 0. And in this case, the zeros would be x is equals to 2 and x is equals to 3. As at both the points, the polynomial becomes 0, as p of 2 will always be 0, that is 2 square minus 5 into 2 plus 6, which turns into 0, and p of 3, 3 square minus 5 into 3 plus 6, that is 0. Now, let's finally explore the relationship between zeros and coefficients of different types of polynomials. This is crucial for understanding how to calculate zeros and relate them to terms of polynomial. Talking about linear polynomials. A linear polynomial is a polynomial where the highest degree of a variable is 1. It is of the form as ax plus b, where a and b are constants and x is the variable. So to find the zero of a linear polynomial, we simply use the formula of minus b by a, where b is the constant term divided by the coefficient of x, that is a. For example, if there is a linear polynomial p of x as 3x plus 6, so the 0 will be minus b by a, that is minus 6 by 3, that is 2. And when we substitute 2 at the place of x, the whole equation, sorry, this is minus 2, so the whole equation becomes 0. Next, we have quadratic polynomial, which is a polynomial with the highest degree of 2. It's in the form of ax square plus bx plus c, where a is not equals to 0 and x square is the highest degree term. Let us say that the quadratic polynomial has zeros as alpha and beta. So these are important relationships between these zeros and coefficients. It is stated like the sum of zeros is given by alpha plus beta and should be equals to minus b by a. That is the negative of the coefficient of x divided by the coefficient of x square. While the product of zeros, that is alpha into beta, should be equals to c by a. That is constant term divided by the coefficient of x square. For example, take p of x as 2x square minus 5x plus 3. So the sum of zeros, that is alpha plus beta, should be equals to minus b by a, that is minus of minus 5 by 2, that is 5 by 2, while product of zeros, that is alpha into beta, should be equals to c by a, that is 3 by 2. Lastly, let's talk about cubic polynomial, which has highest degree of 3. It is in the form of ax cube plus bx square plus cx plus d is equals to 0, where a should not be equals to 0. So for a cubic polynomial, let us say the zeros are alpha, beta and gamma. So there are three important relationships. The first one being the sum of zeros, that is alpha plus beta plus gamma, should be equals to minus b by a, that is the negative of coefficient of x square divided by the coefficient of x cube. Then the second is the sum of products of the zeros taken two at a time, that is alpha into beta plus beta into gamma plus gamma into alpha, should be equals to c by a, that is the coefficient of x divided by the coefficient of x cube. And the third one is the product of zeros, that is alpha into beta into gamma, should be equals to minus d by a, that is the negative of constant term divided by the coefficient of x cube. Now let us take an example of a polynomial 2x cube plus 3x square plus 4x minus 5. So the sum of zeros, that is alpha plus beta plus gamma, should be equals to minus b by a, that is minus 3 by 2. The product of zeros taken two at a time should be equals to c by a, that is 4 by 2, that is 2. And the product of zeros is equals to minus d by a, that is minus of minus 5 by 2, that is 5 by 2. So we have pretty much covered everything from linear to cubic polynomials, the standard form, the relationship between zeros and coefficients, and how to find the zeros. I hope this video might help you to clarify these important concepts. Thanks for watching and see you in the next video.